The 741 op-amp is electronics' most famous building block. Before it, building amplifiers meant calculating incredibly complex transistor math, but this tiny 8-pin chip changed everything. Let's look at the pins. 4 and 7 supply the power, 1 and 5 are used to correct microscopic manufacturing errors inside the chip, and pin 8, it's intentionally left disconnected. The real magic happens here, the output on pin 6 and the two inputs on pins 2 and 3, the inverting and non-inverting terminals. In most circuits, you wire the output back into pin 2. Because the chip amplifies the difference between these inputs by over 100,000 times, calculating the exact voltages inside this feedback loop seems mathematically impossible. But the chip solves its own math problem. That massive internal gain instantly forces the output to adjust like a seesaw, until the voltage at pin 2 perfectly matches pin 3. This balancing act is called a virtual ground. If you wire pin 3 exactly to 0 volts, pin 2 gets forced to 0 volts as well. It acts like a short circuit to ground but draws absolutely zero current. So instead of doing pages of complex transistor physics for every single circuit, this one 8-pin chip lets you calculate massive voltage gains using basic middle school algebra.